Algebra 1 Common Core, Unit 7, Section 3, Transformations. So transformations is something you're going to talk a lot about this year and next year, and in Algebra 2. It comes again and again and again. These are not things that are limited to quadratics. This is just the first time that we show you because it's very easy to see them on quadratics. But it could be anything. In geometry, you're going to do it with triangles, not even stuff on graphs. And just to tell you exactly a little bit about what each one is, now for this, we're just going to talk about translating, reflecting, and dilating. Rotating is also a transformation, but we're not going to do that on graphs. You will do that next year in geometry. But a translation is like a shift, moving, up and down or side to side, left and right. But a reflecting, I think you know what a reflection is. We can reflect something over a line. And a dilation is kind of like a stretch. It can be a couple of different ways. If I actually, let me, take a triangle out real quick and I'll show you. If I were to take this triangle, now moving it side to side is translating. So like right now I'm translating this triangle to the right, translating it down, translating it left, translating it up. So you could translate it all over the place. Reflecting would be if we, kind of had a line, drew a line, and like reflect over this line, and I can make that look like, let me clone that and flip it like that. Like that would be a reflection, where I reflected it over that line. And a dilation is a stretch. Now you could dilate the whole thing, make it bigger or smaller. You talk a lot about that in geometry. Or on graphs, what you'll see is we'll just dilate certain dimensions. Like I could just dilate it vertically, or I could, compress it, or dilate it this way, that type of stuff. And so that's the different types of stuff you'll see. So, first the translating, the shifting, the side to side, up, down. That's probably, the most important thing for you to take away from this video, is how to tell the difference between when a graph is being moved up and down or left and right and so on. And the importance here is remembering the concept of, I think, inside and outside. Now we're going to use the most basic quadratic we can have here, and that's y equals x squared. That's this graph here, y equals x squared. And what happens to it when I do a +3 on the outside or a -3 on the outside? And so that would look like y equals x squared plus 3. That's what this is. Or this one is y equals x squared minus 3. And what you're seeing here, when you do plus or minus a constant on the outside, or after the x squared, that is your up and down shift. Your up and down translation is when you do a plus or minus on the outside. That when you +3 on the outside, it moves up 3. If you do a -3 on the outside, it moves down 3. So that's really it. Let me show you in Desmos what I'm talking about. So remember that program Desmos? So I could type in here y equals x squared. And below it, I could do y equals x squared, plus 2. And here, I'll show you that the one in blue is the original. The plus 2 is up 2. If I were to change that plus 2 to a -2, it's down 2 from the original. Everything's moved down 2. In Desmos is actually a nice utility where I could change it to plus C for constant, and then it'll give me a little slider, and we could kind of play around with it. And so you see that if I change that plus C to a plus a number, as that number increases, it goes up. And if I minus a constant on the end, it goes down. The outside shift is your vertical shift, and plus is up, minus is down. So outside, plus up, minus down. Remember that. On the inside, now what do we mean by the inside? Well, on the inside is in with the x squared. Like notice this, this +3 is after the x squared. Well, I could also do sorry, I just wanted to get rid of that eraser icon. Instead of the +3 after the x squared, it could be a y equals +3 inside with the x squared. Or y equals minus 3 inside with the x squared. And so that's the difference of, inside and outside. And what we see here is when we do plus or minus on the inside, plus or minus a constant on the inside, that's your left and right shift. What's a little counterintuitive, though, is you would probably guess plus means right, but it's not. Plus actually means left. When you plus a constant on the inside, you actually move to the left. Like this plus 3 on the inside went to the left of our original, and a minus on the inside goes to the right. Again, I could illustrate this in Desmos for you. That here we have, again, regular y equals x squared. And then if I change this to, I'm going to have to do parentheses, x plus 2 parentheses squared. So here is a plus 2 on the inside. You see the green graph is to the left. If I change it to a minus, we go to the right. Or again, I could change it to that slider option. Or let me do it as plus some constant. And as I move to the positives, it goes left. As I move to the negatives, it goes right. So it's a little bit of the opposite of what you would guess. When you're doing the vertical shifts up, down, plus is up, minus is down. But inside, plus is left, minus is right. And then so those are your translations, your side to side, up, down. For reflections, we're really only going to talk about one basic reflection here, and that's reflecting over the x-axis. And when you reflect the x-axis, it's because you throw a negative in the front. So if instead of x squared, you do negative x squared, that reflects it over the x-axis, and so it goes flipped upside down. That's the only reflection you need to know about. The only dilation, these are your dilations, is when you put a constant in front of it, like y equals 3x squared. That's a dilation. That's going to stretch it. It makes it narrower. Let me show you again this in Desmos. This is a good thing to see in Desmos here too. So get rid of that and change this again to, instead of just x squared, what if instead of x squared we had y equals 3x squared? You see it's more narrow. But let's change that to a constant. And I'll use that slider and I'll show you how that works. So as we increase this constant, so 1x squared, 2x squared, 3x squared, 4x squared, 5x squared, 6x squared, 7x squared, it's getting more and more stretched vertically, which makes it narrower. And if we actually go less than 1, like a half or a quarter, you see when I get down to under 1, that actually makes it wider. To the point that when I get to the negatives, it reflects over, because when you put a negative in front, that's your reflection over the y-axis, the x-axis, excuse me. So that's these rules here. Remember, outside plus up minus down, inside plus left minus right. Negate is a reflection, and a coefficient is a dilation. So real quick, let's just do an example of this on a graph. So first, we want to graph y equals x squared plus 6x plus 5. Now, I'll save you a little bit of time here and just tell you that these coordinates here, -6, -5, -4, -3, -2, -1, 0, I believe they go 5, 0, -3, -4, -3, 0, 5. And you could type this in your calculator if you'd like to confirm that I'm right, but I'm pretty sure that I am. So let me just plot this graph real quick. So -6, 5, -5, 0, -4, -3, -3, -4, -2, -3, -1, 0, and 0, 5. So this is your quadratic right here. And the roots, well, we have a root here at 0, -5, a root here at -1, 0, and our vertex in the middle is -3, -4. What they're asking, state the roots in the vertex, we did that. What they're asking you to do down here is describe the given transformation above and state the new roots in vertex. Well, what do these transformations mean? Well, this +3 on the outside means up 3. And so if we were to take all of these points and move them up 3, so if your vertex were to go from here up 3. And your roots, up 3, up 3, up 3, up 3. And these other points actually would go off the graph, so I'll just plot these. And so did the roots and the vertex change? Yes, absolutely they did. The vertex was here. The new vertex is here. It went up 3. The roots were here. They're actually now here. We wouldn't call these the roots anymore because they're not on the x-axis. So the roots completely change when you shift the graph, up and down or side to side. Any translation will change your roots and change your vertex. Let's not worry about stating them. Let's just get down what's happening here. How about this -2 on the inside? Well, -2 on the inside is side to side. Remember, minus is right. So this is a right to translation. So again, I'll work with my original green graph here. If I moved all the points to the right to the right to, would land here. And again, all of the vertex moved, the roots moved, everything changed there. The last one here, if I throw a negative in the front, this is the reflection over the x-axis. And I'll do this one in purple here. And again, looking at your green graph, reflecting that over the x-axis, reflecting that over this line, any points on the line aren't going to change, so these actually wouldn't move. So reflecting doesn't change your roots, but it changes everything else. Like this point is 5 above the x-axis, now it's going to be 5 below it. And these points, instead of 3 below, 3 above, and 4 above, and 3 above, and so on. So this is what your original graph would look like if you were to reflect it over the x-axis. And notice that for that reflection, the roots actually didn't change, but the vertex did. But really, being able to, at this point, look at these and say this means up 3, right 2, flip upside down, or reflect the x-axis, that type of thing, that's really the key here. You're not going to be asked to do all of this on one graph. You may be given one parabola and asked to do one of these things. That's more likely. But that's your transformations. And remember, you could always kind of experiment with these in your calculator, and that really helps you learn them. All right, see ya.